Well, here's a few news articles. This one's interesting from Rachel Toback, who is a very famous social engineering expert. PayPal apparently has a Twitter tip jar where you can tip people. Somehow if you have, people are asking about the summer research. If you go to this page, my homepage, and you look at the summer research, the way to contact me about this is on Twitter, which you'll see down here. All three of us are on Twitter. You can try sending me email, but I just noticed an email that was a month old that I never saw. Email, I frequently don't see it. So if you actually want to reach us, Twitter's the way to do it. Anyway, what Rachel found is when you send money to anybody with the tip jar, it sends you their home address, which is a pretty serious mistake. Twitter said I wasn't accepting messages. Oh, you'll have to send me a public message so I can follow you, and then you can send private messages. Just send me a message and say you're a student and you want me to follow you. Good, thank you. That's important. Of course, that's probably why Twitter works, because I don't get spam. The problem with email is I get dozens of spams every day, and especially now I must get 50 spams about the college cuts. So everything useful gets buried under all the junk. Good. Well, I'm glad you folks are interested in the project. All right, so someone told me about this. Urban told me about this. It's tomorrow. If you want to go to this thing tomorrow, there's a presentation on this vulnerable Android app and how to learn about Android vulnerabilities with it. So I'm using some stuff like this in the mobile device class, but this is a different one that may have different features. Nothing has been decided about the teacher layoffs. The latest plan was that they're not going to lay off any full-timers, and instead we're going to get a 25% pay cut. As far as I know, nothing. There are lawsuits flying around and everyone complaining, and no decision has been reached yet. Supposedly there was going to be a decision by tomorrow, but I'm not sure if that's going to happen either. So Google is trying to get everyone to use two-factor. They're pushing it out. They're pushing it out to a group of people gradually to see how that works out. But certainly everyone would be a lot safer if they can use two-factor, although I'm sure a lot of people are not ready for it. And Fox is really trying to get people killed by being an anti-vax network, pushing this stuff out. Tucker Carlson is, and this is, there's an online database of people that complain about their medical problems that are not verified in any way. And now, of course, a lot of celebrities have died shortly after getting the shot because everybody, half the people in America got a shot within the last couple months. So then when some of them die later, they can say, see, the shot killed you. Whereas there is no credible evidence of that. But anyway, I'm surprised this is legal in America, that you can promote false medical statements that lead to people dying in large quantities on a commercial network and not get sued. I would think they would at least have class action lawsuits and malpractice and libel lawsuits or something like that. We'll see. And the AirTags are Apple's little gadget that you get to find your lost objects, and they said they had made it so you couldn't abuse them, but as these guys point out, they didn't do a very good job. For example, the most common case of abuse is when people are breaking up and having fights romantically, and the wife, say, finally leaves, and the husband is at home, and he wants to know where she is. This is why there are women's shelters, where women can go and hide from their crazed, violent ex-boyfriend who is trying to hunt them down. And if he could just slip one of these into one of her possessions, then they won't be warned. The original plan is, of course, that you would be warned if somebody else's tag was near you, but if you were sharing an account or both on the same airplane, then it wouldn't warn you for a while. And they talk about how there's even a way he can do something like log in every couple of days so it doesn't ever hit the time limit, and therefore it will never warn the person that's in there. So they say it's not as simple as slipping this in a stranger's thing and then following them for months, but there are ways to use these things to stalk people, and Apple didn't apparently put in enough defenses. A recent lawsuit against Fox said that no one who listens to him should take him serious. Yes, that was when they sued him for his statements being false. And he basically defended himself by saying that his show is not news at all, it's not factual at all, it is so ridiculous that nobody should take it seriously. And that was the official position that got him out of that lawsuit, but I don't think that'll get you out of this medical malpractice stuff, but we will see. I'm sure somebody will sue him, and we'll see where it goes. This is a huge problem in America, is the lack of anything to do about false information online. And Facebook now has to handle it. Now that their attempt to launder the decision to kick Trump off through a third body failed, and it kicked it back to them. They do get to keep Trump off for 6 months and pretend it was somebody else's fault. But after that, apparently, Facebook is going to have to make a decision about Trump. And they're trying to avoid that by any means necessary because, of course, whatever they do, half the customers are going to hate them. So Facebook is trying to find some way to avoid making a decision about Trump. But I don't think they can avoid it. So this is the last lecture, Software Development Security. I'm not going to add any new material next week. This class has a fixed amount of material, the CISSP amount, and we'll be through it all. I'll show up to see if anybody has questions for a while, but I don't think there's anything to add to this class. I should mention, if you want to take I think I have before, but I updated this thing. Someone asked me how I prepared for the CISSP exam. And the Cyber Vista. If you want to really get the CISSP, get the Cyber Vista practice exam. This is the latest rebranding of the one I took. That's very good. $150, very much worth it. Practice with this thing as they tell you to, and you'll make it through the CISSP exam well. Anyway, well, let me throw that in the chat in case anybody needs it and doesn't have it. All right. Anyway, if you're trying to get the CISSP, I strongly recommend practicing with that. And let's take a look at Chapter 8, the last chapter of Software Development Security. What about other CISSP resources? Well, you can see here, if you go to this page, I've archived the ones I know about, but a lot of the stuff I've got here is kind of old because I got my CISSP quite a few years ago. But here's I guess I don't have that many other resources. I think all you need is your textbook and that practice test. Remember, the point of the practice test is to learn how they write the questions, which is very strange. The material is in your textbook, but knowing the material is not enough to pass the test. You also need to know how to handle the really strange way they write the questions, and that's what the practice test is for. So I guess there's nothing else I would recommend besides those two. There are a ton of them out there, though. There's tests on here, and there's an official ISC squared study app and such. So there are a bunch of others out there, but this is true in general but especially this one. You really need a real good practice test. This is a very unfair, very frustrating test. Anyway, so software development. So the basic concepts of programming. The only thing your computer ever runs is machine code. This is baked into the hardware of the central processing unit in the way they lay out the transistors. And the only thing the processor ever runs is machine code in a binary form. All the rest is an illusion for humans. That's why I remember I had students ask me, and the computer does not know if it's running Windows or Linux or Mac or Mac OS. It's just running machine code. So humans don't like to write machine code, although you can. They like to write a higher level language like C, which is closer to human language and easier to understand. And then that's compiled down to machine code to run. And if you want to reverse engineer machine code, you can write it as assembly language. Assembly language is a slightly human readable way to look at a machine code. Very few people write directly in assembly language, but reverse engineers work with it a lot because all they have is machine code and they do not have access to the source code. So compilers translate source code into machine code. There are interpreters that translate each line of source code into machine code one at a time instead of making a separate file to run. And there is bytecode if you use Java, for example. Java creates machine-independent code. So it creates partially compiled bytecode, which can then be run on any platform in a Java virtual machine. So your developers only have to write the program once, and it will run equally badly on all platforms in the Java virtual machine. A WebAssembly language, that's a very good question. I've heard of it, and I don't think I know. Let's find out. A binary instruction format for a stack-based virtual machine code that can be run in the browser. A low-level assembly-like language provides these languages with a compilation target so they can run on the web like JavaScript. Wow. Well, this sounds like then it runs in the browser. So it would use your browser as the platform. So apparently machine independent. It sounds pretty interesting. It sounds like it may be a competitor for Java in that regard. But I don't know any more than what I'm just finding by Googling it. It's a very good question. I would like to, this is actually pretty interesting. Let me save this pink, because I might want to throw this in some of my classes. WebAssembly, there. It's not a bad idea. From Mozilla, good. Might be good to like compile some and take a look at it. A very interesting idea. Something that runs in a browser, sort of like JavaScript. All right, good. Anyway, all right. So procedural languages create subroutines and things called procedures and functions, where you can make a block of code that's called by another function, like C and Fortran had that ability, the really old ones. Then there are object-oriented languages, where you can define an object, and then you can define another object on the first object. So you could define an object called employee, and then you could define an object called manager, which was based on the employee class, where it inherited all the attributes and methods of an employee and then had more. And that's what the most modern languages are, like C++, Ruby, and Python. They're object-oriented, so they can have these objects and inherit properties from other objects. All right. Metasploit, for example. Metasploit was written in Ruby, and I think this is still from when it was written in Ruby, although I can't immediately tell what this is, but this is object-oriented code, and you can tell from these double colons. This is a hierarchical list of an object here and a sub-object and a sub-object and a sub-object, that sort of thing, or a member of the class, something like that. There's various terms. This Perl? Yeah, I don't think it's Perl. I don't think Metasploit's in Perl. It was in Ruby. I think it might be Ruby. Either it was in Ruby, and anyway, it is definitely an object-oriented language that Metasploit is written in. And all right, and then there's these fourth-generation programming languages that supposedly automate creation of code. I've never used any of these. Cold Fusion, Progress, Oracle Reports. It sounds interesting. I see sometimes websites written in Cold Fusion, and I know it's very expensive, but I've never used it. Anyway, all right. So there's computer-aided software engineering to help you create the program. So there are tools and workbenches and environments that help you write these things. Programming environments like Visual Studio that give you a whole lot of features to maintain your library of code and such. And all right. So all these things are part of the computer-aided software engineering system. So a top-down approach is where you start with high-level requirements that you need, and then you write modules to achieve those requirements, to accomplish the goal. The bottom-up, where you start with low-level technical details and move up. And those are common with object-oriented languages. You would define a little object and then define the methods and attributes and move up. So there's software. Closed source is the most common type, like Microsoft Office and Microsoft Windows. The source code is written inside a company, and it's a secret, and you don't get the source code. You never can get it. It's a proprietary secret. Open source is the opposite, like Linux, where the code is all put on public places like GitHub or elsewhere, and everybody can see the source code, and everybody can modify the source code and make your own if you have enough skill. Free software can be free, or it can be free in the sense that it is open so you can modify it. So the freeware costs nothing, shareware and crippleware have trial versions or limited versions. And then there's licensing. Public domain is free to use for any purpose, although there are some subtleties like whether you're allowed to like brand it and sell it and keep the money. There's proprietary software like Windows. There's an agreement that limits what you're allowed to do with software. And so here's some of the open source licenses. The GNU public license and Berkeley software distribution and Apache are just various licenses that give you some degree of freedom and some restrictions, like they often require that if you modify it, you must include the source code with the modification or a reference back to the original source or something like that. All right, so to develop this stuff, there are methods to organize your scheme. The old-fashioned way to do it is the way you have requirements, you write some code that goes to the next system you're trying to accomplish, then the software requirements, analysis, program design, coding, testing. You just have steps, like an assembly line. You do your part, you do your part, you do your part, you do your part, and then we're done. Boy, it would be nice if it was ever that simple. In reality, at almost every level, you will discover that there is a problem, which means you have to go back and change what happened at an earlier level. So you actually have kind of a mess. This is kind of what you really have. You pass it to the next level. They then pass complaints back, check it, then you send it back. And so you have a complicated back and forth pattern of real travel. All right, then there are other ways where you have the steps overlapping, where the teams blend into looking at what the next team is doing to try to make sure that they understand what the next step is doing to avoid all that back and forth travel. That's the sashimi model. And then there's Agile, Scrum, and extreme programming. And the idea is that people will move very quickly through the code, and that they will write the code really fast and not be held up with the parts that programmers don't like documentation. Scrum is where instead of continuously passing it to another team for each step, you have one team that takes it through all the steps. And then, of course, you don't have the problem of different teams having a different interpretation of what you're trying to do and sort of going off target. Your original team will have their idea what they want, and they will just carry it all the way through. That's Scrum. And there's extreme programming, where you have pairs of programmers working together. This way, they're constantly talking to each other and hopefully spotting each other's mistakes. And so, all right. Then there's a spiral technique, where each round is a project, and you can use the waterfall model, and you have many rounds, and you perform risk analysis on each round. So this is spiral. You have ideas, you do a risk analysis, you do a prototype, then you have new requirements, another risk analysis, another prototype, then you have new requirements, and you go around and around and around. And eventually you get it working well enough that you have a detailed design and you can have an acceptance test and implement it after you've been through enough cycles of iterations. All right, then there's your rapid application development, using prototypes and dummy GUIs and backend databases to try to quickly make a simple version of it to test and then move to an implementation version. So prototyping, you make mock-ups where the customer sees realistic results to see if that's what they really want before you bother writing it all. This is true for people who do indoor remodeling too, as well as programming, customer and web design. Customers come to you and they say what they want, and when you make it, it turns out that's not really what they want. And they don't really understand how to express what they want, and they don't really understand the limitations, so you have to go back and forth with the customer. Microsoft pushes the software development lifecycle, and this is where you put security in every phase, and it's also in a NIST publication. And so you have initiation, development, implementation, operation, and disposal. And you should start with the security plan. The sooner you think of security, the better. So you prepare a security plan, then you define the need for this software product and its purpose. Then you assess how sensitive it is. Then you determine your requirements and incorporate them into the specifications. Then you implement it, including testing and accreditation, which makes sure that it meets your expectations. And then you have an operation and maintenance. This is the part that many people don't plan for. Once you're done making it, you're probably going to have to keep on bug fixing, updating and stuff. So you're going to have to be handling the maintaining of the code while you use it, audits and monitoring to detect problems and updates to fix them. And then when you're done, you have to dispose of it, archiving the data you want to keep, and destroying all the leftover data that you don't want to keep so that it doesn't get exposed somewhere. All right, so you got integrated product teams for all these things. And there's the concept of Softrow Escrow. I'm not so sure I've ever seen this actually work, But the idea is, if you buy a proprietary software product from somebody, they could put the source code in escrow at a third agency. You're not allowed to see it, but if they go broke, then you get the source code. One thing I do know is there was a law passed a while ago that if you do buy a product and the company goes out of business, you are legally allowed to reverse engineer it to figure out how it works in order to patch it and maintain it. All right. And so you have somewhere a code repository, especially if you have a big team, especially if you have a global team. You've got a bunch of programmers that need to get at the code, and they all need to update to the same version. So you need version control. GitHub is the most popular one. Everybody puts their code on GitHub, and there's a whole system of putting an update to the code and reversing updates and keeping track of who made the updates and so on, and forking from it and so on. The problem is a lot of people put code public on GitHub that shouldn't be public and contains secrets like passwords and API keys. Anyway, but there are a variety of code repository systems, and you do need one of them if you are a large shop. Really, if you're just an organized shop. Does that apply to end-of-life software? I do not know. I don't think it does. I think, for example, if you have a copy of Windows 2008 Server, just the fact that Microsoft applies end of life to it does not mean you're legally allowed to reverse engineer it. But I don't know. You'd have to check with a lawyer. The company is not, I know exactly. If the company has decided to end support, I don't think that means you're legally allowed to reverse engineer it because there's a later product they want you to buy. But it's a good question, and I don't know the details. The case I heard is when the company is broke and there's nobody to help you anymore. Anyway, so APIs are a huge issue. These are the systems that take requests from another computer to get some data. So if you have a Facebook app on your phone and you open it to see Facebook, it passes a name and password up to Facebook. That sends down a cookie to decide who you are, and then you send a request for data to the API saying, I want my page, and it passes you your page, but hopefully nobody else's page. And the API is what makes that work. And it turns out that an enormous number of APIs are very insecure. The most common mistake is they just let anybody access anybody's data. It's not actually correctly limited to only the logged in user. All they do is they write an app that will only ask for the right user, and they don't think about how somebody might use another product like Burp to make extra requests to ask for someone else's data. So there's an API toolkit from OWASP talking about these considerations, just like the OWASP top 10 for webs. You got to have authentication, access control. That's what I was just talking about. You have to make sure you know who's connecting and make sure that they're only allowed to access resources they should be accessing. And then cryptography and error handling and these other issues, the same as a web app. Yeah, the code may be inherited by a later product. I think, for example, I think Microsoft still owns the code for early versions of Windows, and they could, in principle, reuse that code or sell it to somebody. So I don't think you're allowed to have it just because that product's out of support. The company still exists. I think this law only takes effect when the original entity that owned it no longer exists and they did not transfer ownership to someone else. All right, so when you make your software changes, then you try to have an orderly manner to do this. So the NIST technique is a configuration management plan, a configuration control board, item identification, change control, and monitoring, just like the other changes we've talked about. And then you have DevOps. There's a book, by the way, I don't know if I mentioned it in this class. If you want to understand DevOps, you should read The Phoenix Project. This is a fantastic book. I did not understand DevOps until I read this book, and it is a fiction book, and it is very good. I'll put it in the chat. This book explains what's going on here, and I'm glad it's in these slides because I really wanted to talk about it back here. So this is really what happened as we went through the generations of, first they tried to write software this way, and then they found out that a later step kept pointing out that something was wrong in an earlier step, so then they tried this way, and then they tried this way to try to make it so that you'll be involved in the next stage, and the really final limit of this is DevOps, where you regard your part of the company as a company and the next person in line is your customer, and you have a very strong feedback loop from the person you hand it off to come back to you to tell you if what you did messes them up. That is your number one priority, is to make sure that you are not messing up the next person in line. And then you automate all your tasks. Everybody in the whole company has to be a coder, and everybody has to know how to automate their routine tasks, including the security tests, including the functionality tests, so that what you want is after a while, you don't do things that will mess up somebody later in the chain, and the normal activities are automated, so if somebody wants to do something, it will just flow through the chain quickly. This is what Amazon has. I think Amazon might have invented it. Amazon has 144,000 rollouts of new code per day. So if somebody has an idea about changing Amazon, that can be deployed to the customer in 5 minutes, unless it fails some of the automated tests. But if you have a great idea to try something, you can suggest it, get it approved, and then it goes right out to the customers, zipping through the system, which is automated, unless there's something wrong, and then it will be held up longer. And that means your company switches from being a fixed company that puts out a product and maybe 6 months later there's a new version into like a living object, which you can adapt quickly in real time to changes in the marketplace. And so you can do A/B testing. You can try putting 2 books up on the front page together for 10,000 users and wait an hour and see how many they sold, and then put a different 2 books on the front and decide which one is better, because you can change things quickly. And that's DevOps. It is a much more efficient kind of company. It requires a whole different kind of management and a whole different rearrangement of the incentive structures inside your company. The disorganized kind of company that those models fit is the kind where individual blocks of your company will find that the way to succeed is to pass trouble onto someone else and mess up some other part of the company for their gain. And DevOps is to reorganize the company so that that is never in anybody's best interest. So everybody is actually doing what will make the product be produced as quickly and as accurately as possible, which is much better once you get it set up. It requires a whole different idea of how to manage the company. Anyway, it's very hot these days. Everybody would like to move to DevOps, and it's very different than the ordinary way a company is structured, and explained in that book. Anyway, let's take a look at a Kahoot, which I got them here. Okay. A, all right. All right. All right. I guess that's it. All right. All right. So what is the code? It's most close to English. Okay, source code, of course. All right. All right, so what method uses the same team for all the steps? That's Scrum, a rugby term. I know nothing about rugby, but that's apparently a rugby term. All right, how about prototypes and dummy GUIs? That's RAD, Rapid Application Development, I think. All right, and what's GitHub? Yep, good. All right. So, all right. So, databases. What I used to do. I was a DBA long ago. So a database is a group of data that you can save and find records in and add records to. So you have queries that search through the database. There's some way to insert data, some way to delete data, and there is some kind of database management system that controls how you do all that. All right, there's a database administrator, the person authorized to do those things to the database, add and delete records. And there's typically a query language, the most common one being SQL, structured query language. So there are things you can do to attack databases. There's an inference attack, where if you have low privileges and you can only read the low privilege data, you are able to deduce something about the high privilege data from the low privilege data. For example, if you have a list of phone numbers, the ones that are not in the list might be the ones that are the high privilege ones. And then there's an aggregation attack where you combine many of those records to deduce high privilege data, which is a similar technique. Both of these are ways to learn something that exceeds your security clearance by combining a lot of facts from lower security clearances. So the most common database is a relational database, and we'll talk about these other ones. But the relational database is the most common. You'll have tables like this, a table of users and a table of social security numbers, and you'll have some field in common, like username, that you can connect these tables with, and then all this information can be easily found to match one of these people. So a database is the object that contains tables. A table is something that contains fields and records. The fields are the columns, and the records are the individual entities in the database. All right, so that's tables, have rows. There's a primary key somewhere, which is the unique identifier of a row in the database, usually some unique identifier like a social security number or a customer number. And you join the key in one table with the key in another table to join two tables together, to combine information from one place to another. There is integrity, which is the condition of the database obeying certain logical rules, such as if you have a primary key, like a social security number, no two records are allowed to have the same primary key. You can't have two people, two customers or two employees with the same social security number. It must be unique. That's one of the integrity properties. And so then there's semantic integrity, like the money fields must contain only digits and not letters. And then there's the integrity that you must not have a null primary key. Every record must have a primary key, and the primary key must be different than all the other primary keys. That's why every company you deal with, like Safeway and Kaiser and everybody, gives you a customer ID, and that number is never used again, so they can tell who you are, and when you buy something and when you take a class and whatever you do with them. That's how they keep track of who you are, because people change their names and two people have the same name and so on. They give you a unique number to keep track of who you are, and that's the primary key. So here's a table that lacks integrity. Here's sick time. That's supposed to be a number of days, but here's something else that's not a day in there, so that violates integrity. And here's another problem. Here's the social security number, which should be the primary key, but there's two different records with the same social security number, so those are both failures of integrity. And a proper database will enforce referential integrity. It will not let you put in data that breaks these rules. When you try to put it in, it will reject it so that the table maintains its integrity. Then there's an issue of normalization. If you, oh, is Nexus 6 a replicate? Oh, I thought it was a phone, but it could have been. Anyway, database normalization. Here, this is why, I don't know, back in the old days, I used to get paper mail, and I would get like 3 or 4 copies of the same catalog. And this is because they combined lists of names and addresses, and they ended up with redundant records. So there are different normalization forms, but the point of normalization is if you have a database where there's, say, an address in one table, and then there's another copy of the address in another table, then you are wasting space, of course, by saving the same address twice. But what's worse is when the address is changed, it might get changed in only one place, and now you have an inconsistency. So there should just be one place where everything is stored, and you should make sure everything is connected properly to find that place. That's what normalization does. And there's a series of normal forms that you go through to get rid of all the unnecessary extra copies of data in a database. That's called normalization, and it means that your database is more likely to maintain its integrity, more likely to have less errors because you don't have extra unnecessary copies of data. All right, so then there are views that let you see the data in some way, like your Facebook page. Your Facebook page is a view into a database that contains everybody's Facebook stuff, and it shows you only your Facebook wall, which is chosen from all that data. And it's the same thing as a cash register, where you're buying something like hamburgers, and they're seeing your purchases and how much money you have to pay and nothing else. There's a whole database with all the purchases, but their form there shows them only the purchases relevant to the current activity. So a data dictionary is like the database schema, describes the structure of the database, the names of the tables, the names of the columns, what kind of data goes in each column, how the tables are related to each other. So here's a simple schema. You have an employee table with 3 columns, and here's what the types they are, what format they have, and there's an HR table with these columns. That's a schema. All right, so you can have data definition language and data manipulation language. The most common one is SQL, which can do it all, and there are many versions. MySQL, the open source one, Microsoft SQL called ANSI, Oracle SQL called PL, and there's many others. And they all do pretty much the same thing, but the detailed syntax is a little different. So you have a way to create a table, a way to delete a record or a table, a way to select a record to find data, a way to insert data, and a way to update data, like changing an address in a record that's already there, and you end up with commands like this: select everything from employees where title equals detective. This will find all the employees with that title. So then there are hierarchical databases, like DNS. There's a root of the whole DNS, where these ones only have records for the top-level domains like .com and .org. And so if you want to look up, say, support.google.com, you will have to first go to the root to find out where the .com is, go to the .com to find out where google.com is, and go to google.com to find out where support.google.com is. So you have a hierarchical, tree-structured group of objects that work together as a giant distributed database. No one of these objects has all the data. They each have a portion of the data, and they work together to efficiently distribute the data to people who need it. There are object-oriented databases designed with object-oriented programming. And here's the issue of database integrity, preventing unauthorized modification. If 2 people try to update the same record at the same time, something that happened all the time when I used to work as a DBA, we had a phone bank with a room full of maybe 100 operators taking calls, and people would be calling in doing things like changing an address, and 2 of them could, in principle, try to change the same record at the same time. So if that happens, you have a locking system where one of them gets to change it and the other one is locked out until that first change is done. All right, and so the databases attempt to commit an update. If the commit is unsuccessful, it can roll back, and you keep a journal which logs all the transactions. So highly available databases have multiple servers and multiple copies of tables. and you can replicate it so you have original and live database that are constantly mirrored. So if one fails, the other one is ready to go right away. Or you can have a shadow database where it's a live backup, but it's not used until it's necessary. You can have a data warehouse with an enormous amount of data in it, and these big clusters of hard drives and other devices storing this all. And then there's the activity of data mining, hunting through a vast database like this, like the internet, to find something useful. And that can be used for finding customers to send your advertising to, or to track down credit card fraud, looking through transactions, or many other purposes. All right, so object-oriented programming, your program is a series of connected objects which send messages back and forth. And these are some languages that can do it. You have data and methods in an object. An object provides data hiding. You might, from the outside, just see the object with the object's name, but inside there is more data that you don't need to deal with all the time. It's called encapsulation. So you have objects. Methods are the things the object can do, active components with code in them. Messages are sent from one object to another. And all right, an inheritance is if you make another object based on the first object, it inherits the attributes and methods of the one above it. You can delegate function to another object, so it does the work, and we'll talk about these two a little later. So suppose I have an object called addy, which can add numbers. Then I send it a message, 1 plus 2, and it calculates 3, and that's the output message. So there's an object. All right. Now, suppose I send addy 7 minus 4. Addy does not know how to add, but addy can know to delegate to subby and say, oh, I can handle that for you by passing it on to another method, another object, which can take care of it, and now you get the answer. And here's polymorphism, where instead of passing in numbers, I can pass in strings, and addy will figure out how to combine strings also. So you can have multiple methods, actions performed here based on the type of data that comes in. All right, and here's polyinstantiation, where if I'm top secret and I give it input, I get the top secret level output. But if I'm only secret and I give it the same input, it will give me output, but it will only show me the portion of that output that I'm cleared to see. All right. There are middleware brokers that sit in the middle, like proxy servers, and connect programs to other programs. And these are object request brokers. Corba is an open source one, but there are others like COM and DCOM, Microsoft ones. The component object model and the distributed component object model from Microsoft. These allow code objects written in different languages to interoperate. So you can assemble a program by purchasing or writing code in all different languages and just combining them like Lego blocks to build your final program. There are ActiveX objects and object linking and embedding objects. And they're supposedly on the way out, being replaced by Microsoft.NET, which we're talking about quite a bit this semester in some of the other courses. .NET, like Java, takes a variety of different source codes and combines them down to an intermediate language, which is the same for each of those different source codes. Another way to accomplish the same thing, so you can have developers that prefer to use different languages, but still create a product that uses all their efforts and combines it together. So Corba is the open vendor-neutral framework to do this, competing with Microsoft's proprietary DCOM, and your objects that are created now communicate by interface definition language, so that if you have something like this stuff here, you don't know what language this was written in or care. All you need to know is how to structure the input so it'll work and give you the right output. And therefore this one could be Visual Basic and this one could be C++, and you don't need to worry about that. As long as they obey their specifications as specified in the interface description language, then you can plug them in as modules and have them work in a overall structure. So object-oriented analysis finds all the objects and interactions, and object-oriented design designs it using this object-oriented structure. That's the idea. So here's a network intrusion detection system designed this way. You have a network, you sniff the packets, then you pass that data on to some analysis object, which tries to decide what kind of data it is, and then you go to some kind of alerting object, which will then take appropriate action to tell you, to send out messages describing what it has found. And each of these, might be written in a different language by different developers, and you plug them together. All right, let's take a look at this Kahoot 8B. All right, I guess that's it. Okay, which database uses joins to connect tables? That's relational. Those joins are the relations. All right, what process removes redundant data? Normalization, good. All right, what concept is also called data hiding? Encapsulation, good. And which one of these is open source and vendor neutral? Corba, good. All right.